how you doing? It's Mr. Do the Math here, and today we're going to talk about the factor theorem, right? The factor theorem is all centered around factoring polynomials. We've been factoring polynomials by using synthetic division, and we've been using our factoring skills, greatest common factor, difference of squares, multiply, add, bottoms up. All of those things is helping us to factor out polynomials. And so today what we're going to do is we're going to finally get some synthetic division where we have a zero as a remainder, right? So when you have a zero as a remainder, that means that the divisor is a factor of that polynomial, right? So let's check it out. All right, let's look at this example here. Number one, they want to know, is x plus 3 a factor of this problem here? 2x, this polynomial, 2x to the 4th plus 10x to the 3rd plus 11x squared minus x plus 6, right? So we have this polynomial here, and they want to know if x plus 3 is a factor of it, which means that when I divide this polynomial by this binomial, will I get a remainder of 0? If I do, then the answer is yes. Okay? So the way we can do it is synthetic division, right? We can do it synthetic division. Well, we can do it two ways. Remember the remainder theorem, where you plug in -3 for x, right? So we can do that, plug in -3 for x, or we can use synthetic division. So we're going to do both, right? So first things first, let's do synthetic division. If it's plus 3, this is x minus k, right? So if it's plus 3, that's going to be -3 here, right? And we're going to use the coefficients of all of these terms. So tell me what I'm writing down as dividend. Yeah.
2,
yeah,
10,
yeah,
11, -1, 6.
Good. All right. So we got our synthetic division problem set up, right? The next thing we're going to do is bring that down. Pop. We got 2 here, and we multiply. -3 times 2.
-6.
Talk to me, guys. 10 minus 6. 4. -3 times 4.
-12.
-12. 11 minus 12.
-1.
-1. -3 times -1.
+3.
+3. -1 plus 3.
2.
And then 2 times -3.
-6.
-6. 6 minus 6?
0.
0. So we got 0 as a remainder. So then, yes, this is a factor of this polynomial. Okay? So now, what would our solution be then? What would the answer be if we wrote this out as an equation now? Yes, sir.
2x cubed
2x cubed
4x squared minus 1x plus 2.
Good. That would be the answer, right? That would be the answer, right? Now, let's see if we can use the remainder theorem to do it, right? So again, with the remainder theorem, we're going to substitute in -3 to this whole problem. So we got 2 times -3 to the 4th plus 10 times -3 to the 3rd plus 11 times -3 squared minus -3 plus 6. Okay? We put all of this in, we should end up with 0, right? -3 to the 4th power is 81, so it'll be 2 times 81, right? Plus minus 90, right? Hold on, that's supposed to be to the 3rd, safety. Minus 270, right? Yeah, minus 270, plus 99, plus 3, plus 6. All right? 2 times 81. Is that 162? 162 minus 270, plus 99, plus, let's just say this 12. All right? 162 minus 270, talk to me.
Mr. Nelson,
Huh?
3 plus 6 is 9.
Yeah. I thought this was a 9. Yeah, safe. Here we go. All right, so here we go. 67. There's an 8 there. 0. And then is that 108? -108. Plus 108. There's your 0. Okay. So that proves that that is a factor, right? 0 as the remainder, okay? Let's look at another example. Where should I put it? I'll put it here. Here we go. Is x plus 5 a factor of, is x plus 5 a factor of 3x to the 4th plus 15x to the 3rd minus x squared plus 25. Alright? So, again, to prove, basically what we're trying to see is if we divide this polynomial by this binomial, will we get 0? Okay? And so we can use synthetic division again. I need somebody else to help me out. What are my coefficients for this one?
3 and 15, negative 1, 25.
Good. 3, 15, negative 1, 25. 4, 3, 2. Not quite. I'm missing one, right?
0.
0. Where does 0 go?
In the middle of
negative 1 and 25.
Yeah. So remember, you got to count down 4, 3, 2. I'm missing 1. And then the 0. Right? So let's do the math. Bring this 3 down. So it'd be negative 5 times 3. Minus 15. 0. And then negative 5 times 0.
0.
Minus 1. Negative 5 times negative 1.
5.
0 times 5. 0 minus 5. 0 plus 5. So it's positive 5. And then you got negative 5 times 5, which is negative 25. That becomes 0. So now our answer will be 1 exponent less. So it'll be 3x to the 3rd minus x plus 5. That is our solution, right? All right. And then again, like I said, we can use the remainder theorem. We can substitute negative 5 into this particular problem, and we should get 0. All right, let's look at it. So we got 3 times negative 5 to the 4th power plus 15 times negative 5 to the 3rd power minus negative 5 squared plus 25. All right. Negative 5 to the 4th power, that's going to be what? Yes?
625.
625. So it's going to be 3 times 625. And then we got plus 15 times negative 125 minus 25 plus 25. Right? So these will be the same exact thing. Right? So this will cancel out, and then you got negative 25 plus 25 is 0. Right? So that is the remainder theorem. Now, there is the factor theorem. This is the remainder theorem. This is the factor theorem. We did it to see if this was 0, right? Now, there's one other thing that you can do. Because look, if we have a polynomial like this, right, there's more than one factor here, right? Because when we've been factoring, we've been ending up with a pair of binomials or 3 binomials or something like that. So what that means is, after I work this out and I realize that this is a factor, we want to know what the other factors are. So in order to figure out what the other factors are, we need to factor what's left. Okay? So let's look at a problem where we're going to actually do that. So looking at number 3. Look at number 3 in our example. Number 3 in our example. We have x minus 2. Right? They want to know if x minus 2 is a factor of x to the 4th minus 2x to the 3rd plus x minus 2. Right? So let's synthetically divide it. Let's do synthetic division. So there'll be 2 on the outside, and then we have 1, negative 2, 0, 1, negative 2. Everybody good with where this 0 came from? Yeah? Okay. Let's do the math. So we bring this 1 down, it'll be 2 times 1, which is 2. Negative 2 plus 2, 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 1 minus 0 is 1. And then 2 times 1 is 2. Right? 2 times 1 is 2. All right. So now we end up with x to the 3rd plus 1. x to the third plus 1 is our solution. Okay? So yeah, x minus 2 is a factor. How do I factor out this though? What's the situation here? We did it last week. What does this look like?
X to the third, x plus 1 times x like 3 times.
Yeah, so
Somebody
this
knock
is,
at the door.
come on in, it's over there. So basically, this is x to the third plus 1 to the third, right? So this is x plus 1 to the third power, right? So this is a cubic situation, all right? On the wall, right there, on the board, right? X to the third, right? So we can factor this out though. Let's factor this out, all right? So, no, this, yeah. So let's factor this out. This is a cubic, right? So what happens? We got, yeah.
Oh, never mind.
Go for it.
Oh, okay. So it's it'll be x plus 1.
Right? You get x plus 1.
Then it's x squared
Mm-hmm.
minus x
Mm-hmm.
plus 1.
Yeah. X squared minus x plus 1. Right? Because remember, when we factor cubics, right, it's going to be a plus b times a squared minus ab plus b squared. Okay? That's this situation here. Everybody good so far? All right, cool. Let's look at this last one. All right? You want to show that x plus 2 is a factor of 3x squared minus 2x, 3x to the third, I'm sorry, minus 2x squared minus 19x plus 6, minus 6, sorry, minus 6, right? And then after that, we're going to factor out completely, right? So let's set up our synthetic. So it'll be negative 2 on the outside, and then inside we're going to have 3, negative 2, negative 19.
Don't you need the 0
Where do I need the 0 at,
at
buddy?
the beginning? Because ain't no 4.
Why does it need to be a 4?
It's always a 4.
No, it's not. This is the leading coefficient. 3 is the leading coefficient, so 3 is the biggest one. You count down from 3. 3, 2, 1, 0. Good question, though. All right, so we got it all set up. So it's 3, negative 2, negative 19, negative 6. Everybody understand where we got those from? Yeah? All right, so let's do the math. 3 comes straight down. So it'll be negative 2 times 3, negative 6. Negative 2 plus negative 6, or negative 2 minus 6, negative 8. Negative 2 times negative 8,
16.
positive 16. Negative 19 plus 16,
3.
negative 3. Negative 2 times negative 3,
+6.
positive 6, and then we're left with 0, right? So now, our solution then would be 3x squared minus 8x minus 3. Okay? Factor out completely, right? How would I factor this? Yeah,
Bottoms up.
yeah, we do bottoms up. But first things first, we gotta find the factors of negative 9, that's a and c, a times c, that add to give you b, which is negative 8. All right, what's the factors of negative 9 that add to give you negative 8?
Negative 9 and 1.
Negative 9 and 1? Negative 9 and positive 1. So let's prepare our bottoms up. So we got the x here, negative 9, minus 9, plus 1. All right? Because our a term, right, is greater than 1, we're going to put it underneath the factors, right? And then see if it's factorable. 9 and 3 are factors of each other, so that can change to be 3, right? So it'll be x minus 3 here. 1 can't be divided by 3, so that bottom comes up. Bottoms up, bottoms up. Come on, Ramonte, it's your song, bro.
I'm hungry. British.
All right, so our solution, our factors then would be x minus 3, 3x plus 1, and honestly, the last part, x plus 2, right? Because we did the division for that, right? So we factored out completely, right? That would be our solution. So for this one, our last factor would be x minus 2, right? So that right there is the factor theorem, right? So we've incorporated we've incorporated synthetic division, the remainder theorem, and factorization. Yeah, what's up?
That's x plus 2. Where did it come from?
That came from the beginning,
Oh,
right? So these are all of the factors of this polynomial, right? We took care of x plus 2 when we did this, right? Any other questions?
Do y'all have
Yeah.
keyboard?
On a test, would you want all three of those?
No, so on the test, I mean, I don't know yet. So I'll explicitly ask you though, right?
Okay.
So I'll say like, what's all of the factors? Or I will say, is this a factor? And then factor out completely. So you'll have to do this part and then do this part to get this.
Okay.
Okay? So I'll be explicit about it. So you'll know exactly what I'm asking for. Okay? Any more questions? All right, so if you have any more questions, don't forget to comment below. And if you haven't already, don't forget to like and subscribe. Until next time, Mr. Do the Math out.